what I'm going to be doing in this webinar is to actually show you on these prismatic parts the programming, what was involved to actually create these parts doing in their standard 2.5D operations. And then I'll also compare that to what I had to do in iMachining 2D. And at the end, I'll also show, obviously, what we're aiming at, showing it in iMachining 3D as well. So let's actually get started with the parts. Okay. Let's first take a look at this part on our screen. What you see here is when a customer gets a part like this, the first thing he has to do, and before he even starts machining it, he has to study this part well, because he has to figure out technologically how he's going to machine this part. I'll give you a simple example. If we take a look, for example, in this area alone, this is a very simple area, just between here and here. Okay? Very simple area. But if the person wants to machine it, he has to study it and says, you know what? I have a step over here. Well, I first have to machine it down. I have to create a geometry just for this area, just going down to this step. He has to think all about these things. And then he has to think about, okay, then I still have to complete this area. And then I have to complete the third area over there. These are different technological issues that the person has to first study the part in order to machine it properly. So, me personally, I built the parts. I know this part very well. But even though I know this part very well, I myself also have to think about exactly how I want to machine it. Now let's take a look at just some of the operations that I have over here. If I take a look at this first operation that I have over here, okay, this operation, if I were to, actually I'll just open up the part, just this operation itself. You can see my geometry. The first thing I wanted to do was machine out this area. Okay, so I made a geometry just for this area, having this side as open. Now, if I take a look at my levels, I also had to show that I want to only go down to a specific level. Okay, I don't want to go all the way down because then I'll mill this out. So these are things I always have to take into account. So this time I have to make sure I pick the proper level as well. So I have to click on that spot itself as well. And of course, choose the proper tool that I need. Okay, if I were to go out of this operation and just show you quickly the tool path itself, you can see my pocket operation tool path exactly the way it had to be done. Okay, we'll go into times in a few moments, but this was just done for this first operation here. But like I said, I had to then continue working on into this area. So in my next operation, actually my next operation was just a semi-finish, was actually a finish for this particular operation. And you can see working in this area on the same geometry. Okay? But now I want to go into my next operation, like I mentioned, and I want to mill out the next step. So I have to have a geometry just for that area as shown over here. Obviously, my Z levels have to be different as well. You can see my Z level bottom is over there. And if I show you my operation, the actual tool path, you can see that my tool path is including this area over here only. Okay? Now, my next operation, again being the finish for that, we'll skip over that one, but then we'll go to our third operation, because that I had to do for this area. So just in this area itself, if I were to show the actual operation, you can see the actual geometry was just this area itself. My tool path was working over there. Okay? Now, of course, in my next operation over here, I just did the finish for that operation. Now, I can continue on down, which I will. You'll see that I have different areas over here. For example, I have this area that I had to machine out over here, and this area that I had to machine out over there. Why did I have to do this in two separate operations? Very simple. It may look alike to you, but like I said, I had to study this part. And when I studied this part, what did I find? I found that the depth over here is 29 millimeters, whereas the depth over here is 25 millimeters. So it's two different depths, two different operations. I had to create two different operations, even though it's basically the same type of operation. Okay, because there are two separate depths, and each one of them has their own chaining as well, as I can show you in one of them over here. Okay, we'll just take a look at the geometry. You can see that that's a geometry. And again, one other thing I should note, that when I create these geometries, I always have to mark what's my open edges as well. As you can see, those are in black. Okay, let me continue on down. And if we go to this area over here, you can see I had these steps I had to take into consideration. So we had a chain for that, as well as the steps on the other side over there. Okay, again, because of two different depths, two different operations. Okay. Now let's go to this area over here. This area over here, I had to machine out this pocket over here. Now you'll note when I did this, it only went down to this step. If we take a look at this geometry, okay, you can see that this geometry over here is a little more involved because there is no direct chain going all around over here. There's a little problem over here where it has to do something like this. So creating this geometry is also a bit involved. And I'll just give you a little taste of what creating that geometry is. I'll just go in there and I'll just edit the part just for a moment. I'll do that just for this part. And I'll just create a geometry and I'll show you exactly what's involved. I have to do the following. I have to say, okay, I wanted to have a chain go automatically up until a specific point, and I'll start from here, going up until this area over here. I can't continue on down because it'll continue all over there. Now I'm going to do what we call curve plus closed corners, and I'll click on this area over here. And then I'll just click on this curve, and I'll just accept this the way it is right now, and then it'll mark my open edge as shown over here. So you see, creating a geometry over here is not always straightforward. Okay, I'm not going to accept it because I already have my geometry here. I just wanted to show you what's involved sometimes when creating chain geometries. Okay, as you saw, my toolpath over there was for both sides. I had to create the geometry for both sides, and I did it on both sides. Okay, and the finish for that as well. Now, my next operation, I had these two pockets over here. These two were on the same depth. This and this, however, was not on the same depth. So these had to be a separate operation. Okay? So we had this operation over here, as well as this operation over here for those pockets as well. I can go on just for a moment. You'll see I also have this area over here. So I had a separate operation for that. And we also had these slots over here. I had to do separate operation for that. I had a total of 24 different operations for the roughing and the finishing using the standard 2.5D operations with 12 different geometries. I had to create 12 geometries, 24 operations. Let me just run my simulation on all of these. And we'll take a look at the time. It's doing all the operations. 56 minutes and 33 seconds. Okay? So let's go quickly over here. Programming time for my standard 2.5D. 56 minutes and 33 hours. Now, the programming time for me took about 1 hour. okay, with 24 milling operations and 12 different chains. Okay, it was done all nice and well, but I had a lot of work involved over there. Now, let's open up a different part. Actually, I'll open up the same part. However, this time, this part was programmed using iMachining 2D. Now, you'll note that with iMachining 2D, I still had to create those 24 different operations and those 12 chains, because I still had to work on those same areas. I still have to study the part exactly the same way I did in the 2.5D operations. There's no difference in that. Okay? You can take a look even if I were to open up the first operation over here. You can see I'm in iMachining. I have my geometry just like I had my other part, the exact same geometry. And again, I had to study my part to see exactly what I have to do over here. So again, remember, studying the part is part of your programming time. And there you also have to make sure you're not making any mistakes. Okay? Of course, I have to choose my proper tool and my levels. I have to choose the level, excuse me, the levels as well, going down to that specific step. All this I have to do. The rest, however, is your iMachining technology wizard, your regular technology. All of this is here. Okay? If I were to show you the toolpath, you can see that the toolpath did the trochoidal cut in this area over here. The next operation did the actual finish on the wall, the semi-finish on the wall itself. Okay, just for that area. The next operation, I had to go down and do, again, the next geometry, which was the bottom step, just like I did in my 2.5D operations. Okay? So again, as far as programming time goes, I'm not really saving that much. Okay? The only thing I may be saving here is that I don't have to also put in the feed and rate, because that's done automatically with iMachining. But a normal programmer, would they normally have the tools? What they'll have is they'll have their tools in a separate tool table, and they'll always have their feeds over there as well. Now, the next operation over here, again, this area over here with its geometry, just like I showed you the last time, showing you over here, this operation over there. That's the geometry. And the same thing with all of these as well. We have this area over here, as well as on the other side over there. And we also have the roughing in this area, just like I showed you before, with the same type of geometry. Let's show the geometry over here. You can see, again, I had the exact same geometry that I had to use before when I created this. So again, I want to emphasize the programming time over here as far as creating all your operations can take just about the same amount of time as doing it in 2.5D. A roughing operation for this area and that area as well. This pocket over here, all of these were done exactly the way I did it in 2.5D. Not to mention that I still have to do also the drilling operation, but we'll talk about that a little later. Now, let me just run my simulation. Let me run my simulation using my HostCAD simulation. We'll take a look at the time, and we can see that it took us 19 minutes and 55 seconds. Let me actually run it now for a moment in Solid Verify. Now, there's something over here that we'll see that is very important. You'll see this in a moment. It's doing all our regular iMachining operations here. And note what's going to happen in a moment. We have a crash. Why do we have a crash? Well, very simple. Our holder is actually not high enough over here. But when I work with iMachining 2D, I have to take this into account myself. There's no protection. Okay? This is a major point between iMachining 2D and 3D as well. There is no protection from holders in iMachining 2D. I have to take that into account. I have to know about this beforehand. Maybe have my tool go up, my holder go higher, okay, if I can. If not, then I have to use two separate tools. All this I have to take into account. Okay, let me continue now with the actual simulation all the way through. And you can see, still doing the simulation, but you can see the actual gouging into the part from the holder itself in that particular area over there. Okay? If I were to show you now, the time, again, 19 minutes, 55 seconds, comparing that to what I had before, let's take a look. 56 minutes before, 19 minutes, almost 20 minutes now. The programming time is just about the same amount of time. Number of milling operations, same thing, 24. Number of chains, the exact same thing. So as far as programming time, I didn't gain. However, I did gain 65% in my cutting time. Also, one point you should remember, however, that in iMachining 2D, there was no protection for my tool, for my holder. Okay, now let's go into my next part. Let me close this part here. And take a look at iMachining 3D. What I'm going to do here is, if I were to program if I had programmed everything over there in those other parts before you, we would need about a 2.5-hour webinar. So I saved the time. But since iMachining 3D goes so quickly as far as programming, I'm going to actually program everything over here. But not only that, remember I mentioned to you before that we also have these holes here I have to deal with? Well, aside from iMachining 3D, we also have a beautiful tool that recognizes the SolidWorks hole wizard parameters. In other words, the holes that we created in SolidWorks using the hole wizard are automatically recognized if I use them in a machining process. And I'll actually do it to you because it goes really, really quick. Machining process, you can even time me how long it's going to take to program this part. Machining process, I'm going to use for counterbore holes. Okay? All I'm going to do here now is just choose recognize my geometry. I'll recognize my geometry just by clicking on one of these. It automatically recognizes everything that was done of that particular hole wizard, and you can see them all over here. Okay? And that's it. Insert. You can see those 5 operations were created over there. Okay. That's how quickly it was just for those 5 operations. Okay. I think I talked more than it actually took me to take it. Now, let me actually now continue with my next operation. The next I want to start with is my iMachining 3D. Okay? My target is here. I don't have to create my geometry. As Emil mentioned before, all I have to do beforehand is just create my stock and my target. My target is here automatically. I don't even have to do that. All I have to do is choose my tool. Now, what I'm going to do is I'm going to choose my tool over here, the one that's not sticking out long enough. Okay? Levels. I just want to go down. My lowest part over here is over here. I don't really have to pick it, but sometimes I like to pick it just to show you exactly. Since I'm not milling on the outside over here, I'm just milling in this area over here. I like to sometimes do that as well. And that's it. That's all I have to do. I don't have to do over here. Actually, there's one more thing I do have to do. In my technology field, I just have to decide what my wall offset is. And because we're also doing rest rough in the same operation, in my rest rough area, I just have to tell it my scallop, which takes into account the step up on the part itself. In this particular case, when we're working on prismatic parts, it's the best suggestion is always to work the same as my wall offset. So I'll put that at 0.3 as well. Note in my tool area, we have holder collision protection. I forgot to check that, so I'm going to check that. And let me do the calculation. I want to show you the importance of the whole collision protection. Okay? This is what's going to actually protect my part so that the holder doesn't touch this area over there. How is it going to actually machine it all the way down to the bottom? We'll see that in a moment. Okay, let the calculation finish for a moment, in a moment. Okay, and we'll run my simulation using Solid Verify. You can see the holes were done over there. Take a look what's happening. It's protecting this area over here. No, it's not going to go all the way in over there. It's just going to protect and work exactly where it needs to work, and no more than that. Okay? That's all it's going to do. Now, in this particular case, I really can work with a different tool. So what I'm going to do, just going to change my tool to a tool that can stick out longer than it was before. Okay? Keep the same thing. Just run my calculation again. And this time you'll see, if I have a longer tool, exactly what happens.
So you have seen here what took him there 24 operations and 1 hour of time, how fast he did. He just picked the target and let iMachining 3D do its work. It's like magic, and it works. And not only it's fast programming time, it will show you will save also cycle time.
Okay, now let's take a look again at the simulation. And this time, since there's no problem with this area over there, you can see now the tool is actually going all the way to the wall over there. Okay? So we had no problem doing it now with this tool. So the holder collision is very important over here, and it saves me a lot of heartache. Now, I still want to do a rest material machining, so all I have to do is very simple. Save and copy, change my tool to the different end mill that I need to do the rest. Just go into my technology for a moment and make sure my rest rough is the same as my wall offset over here. And calculate. That's all there was to it. All of those pockets, what I had to do in 24 different operations before, I did it very quickly, simply, in 2 operations. That's all I had to do over here.
Obviously, he picked here a smaller tool to do the rest machining.
Right. So the tool that I picked now, thank you for mentioning that, is that the tool is for going into corners for where the previous operation could not go into. I first used a smaller tool, a larger tool to take out the massive amount of material, and then the smaller tool. If we take a look at this tool pass over here, you can even take a look for the top pass. You can actually see what it's actually going to do. It's going to work only in these corners over here. Wherever it has to work, those are the areas where it's working. Nowhere else. Okay? That saves me so much time. I don't know, anyone who's working in iMachining 2D and does on prismatic parts, it's very simple to understand that this is what they really need. Even if they don't do any of these different types of shape parts, doing only prismatic parts, you can see just over here how much we have to, how much work I did as opposed to what I had to do in iMachining 2D. True, in iMachining 2D, I saved all that cutting time, but look how much time I saved programming here. Okay.
Show us the Excel, Sidney, first.
Okay. 13 minutes and 43 seconds.
Okay, as you see in this table, look at the row number 12, number of geometries. In standard 2.5D milling and iMachining 2D, you had to define 12 different chains. Takes a long time. We didn't show you the time it takes to define all these chains, and you have to really be adept at defining also 24 milling operations. Really, you need to be a very good technologist to decide in what order to make these milling operations, their heights, how they interfere with each other to make sure that there is no gouging of the target. And you see in iMachining 3D, the only geometry is one solid model. That's all. Nothing else. Everything else is done automatically. That's why the programming time goes from 1 hour to 5 minutes, even less, 2 minutes. So basically, as you see, there is saving here in programming time. There is saving in machining time. And the most important thing, there is this beautiful automation where the software is working for you. Here's the technologist working for you. You don't have to be the best technologist in the world. The software is the better technologist working automatically for you.
Okay, what I'd like to do now is I'd just like to quickly show you one more part. Now, the reason why I'm showing you this part, what we looked up until now was the part that's a typical 2.5D part. But if we take a look at this part that I'm opening now, this part, okay, this part over here has to be machined multi-sided. Let me actually take away the stock so you can see the actual part itself. You can see that it has to be machined on this side, as well as this side over here, as well as this side over here. All of this has to be machined. iMachining 3D works just as well over here, okay? Now, if we take a look at all my operations over here, I had to do a total of 26 different operations to work over here. Okay? To do all of this, 26 different operations. Just
He's showing you now if you are doing 2.5D milling.
Right, this is regular 2.5D milling. Now, as far as, I'm not going to show it to you right now in iMachining 2D because you saw already the advantages of the cutting time in iMachining 2D. The amount of operations, I still may have to have the exact same amount of operations. But let's actually start doing it now with iMachining 3D. Okay? And what I'm going to do, I'm going to start from this point on. Okay? And at this point, from this point on, what I'm going to do is I'm going to say, okay, iMachining 3D. I'm going to choose the proper Mac position. I'm working now
Sidney, show us first, please, the simulation of the standard 2.5D milling.
Sure, no problem. Let me just go out of here. Simulation. You can see it's working on all different sides over here.
Do it in Solid Verify, let's see.
Okay. Okay, you can see all the operations that were created over here. Okay? Now I'd like to do is, from this point on, after the face milling, I'd like to start actually with iMachining 3D. And the first thing I like to do is, since I'm working multi-sided, I have to pick the proper side. We have different Mac positions. Again, note the target is here already. Okay? I'll choose the tool that I want to work with. And I'm going to work with this particular end mill over here, 20 millimeter end mill. Okay? My levels, I'm just going to go down to a specific level, only up until that point over there. That's all I need to do. Technology Wizard, you can see my machining levels over here, exactly the way we have it in iMachining 2D. And in my regular technology, just my wall offset and my rest rough as well. Run my calculation. Now, one thing I didn't mention.
So what this one operation replaces is, if you count here under Mach 1, 2, 3, 4, 5, 6, 7 operations. 7, actually, no more.
No, these are drilling operations, but we also have these operations here at the very end as well. Okay. So about 9 different operations altogether that I'm replacing in this particular case. Running my simulation over here. You can see the actual toolpath as it's going across. You can see the iMachine toolpath beautifully over there. If I do this in Solve Verify, you can see that as well. All of this is done. Okay? Okay, now what about my other sides? No problem. Save and copy. All I'm going to do is just change to Mac 2 to work on this side over here. My levels this time, I'm just going to go down to that surface over there, 5 millimeters. And calculate. I'll continue on down. Again, save and copy. This time, Mac 3. Okay? This side over here. My levels, again, up until that surface. And calculate. Let's run my simulation now, actually, on all 3 of these operations that I had over here. You see the bottom and the top. All of this was done.
And remember one thing very important, that iMachine 3D always remember the updated stock from the previous operation. So when we worked from one side, and then he went to work from the other side, iMachine 3D knows what is the updated stock that remained from the first operation. This is a great advantage.
That's very true. When I go into my geometry, you can see that it knows exactly what's actually left over. So if I'm working over here, it will know to work only up until this whole area over here, up until that step, does not have anything to take away. That's why it didn't work over there. It knows this automatically as well. This in itself, you can see exactly where the whole point behind this is basically to show the difference in the amount of time I have to also work in programming as well. Not only machining time, but the programming time as well. How much time I'm saving programming these parts.
And also, you don't have to be the superior technologist. You can be just a regular technologist, and the software is protecting you, doing the gauge protection of the holder, knowing the update stock at every point. You don't have to make mistakes in defining geometries. You just pick the solid model. It's a different world.
That's right. Because if you remember, if I look at this particular part again in the beginning, as an experienced person, I have to study this part. I have to see all my different step downs, my different levels, to check if these levels are the same as this. To check all of this, I have to check beforehand and decide what kind of technology I want to use. And that's for an experienced person. And as Aniel said, with iMachine 3D, your experience level can be not as the most experienced machinist, but your regular, everyday machinist.